Hi, this is Professor Teixeira, and I'm gonna show you how to solve a lower tail test about the population mean when I know the population standard deviation using Excel. So this is the problem we have in our slides, and we're talking about the Hilltop Coffee, and they want to figure out if the claim that is made about the large can of coffee that contain 3 pounds of coffee, they want to make sure that the large can of coffee has 3 pounds or more. This is our null hypothesis. Okay, and the alternative hypothesis is that the can of coffee has less than 3 pounds of coffee. Okay, so this is the problem, and we worked on that in class. So these are the null and alternative hypothesis. This is important because this is a lower tail test. I'm gonna use this information to determine that is lower tail. Okay, so going to the Excel file, and after downloading it, you have here this is the file in class mean known, and then here you have the weight for the cans of coffee. So here we have 35 cans of coffee and their weights, and here we have information that we're going to fill out. Okay, so the population mean is 3 because it's given in the problem, and we use that information to set up the null and the alternative hypothesis. The population mean is 3 based on the problem, which says that it's 3 pounds of coffee that they want to test. Because this is a problem that I know the population standard deviation, I have to find out where the population standard deviation is, and here it is. Okay, 0.18. So I'm going to use this information here. 0.18. This is the population standard deviation. Now I'm going to compute this information based on the sample. Okay, so what's the sample mean? Sample mean, you know, that is the average. The sample size, you know, that use the equal count function, count, open parenthesis, and then you select the raw, the range of data, and then you can compute the standard error of the mean. The standard error of the mean is going to be equal to the population standard deviation divided by the square root of the sample size. So this is how we compute the standard error of the mean. Okay, now I can compute the z statistic, which is my test statistic that compares if the sample mean deviates from population mean, taking into account the standard error of the mean. To do that, I'm going to use the standardized function. I'm going to standardize, and the first information is here, this x. This x is the sample mean. I'm going to standardize the sample mean, comma, then I type comma, and I have to enter a mean, which is the population mean. So I'm going to standardize the sample mean in regarding to the population mean. Then I'm going to type comma again, and then select the standard deviation, which is the standard error of the mean. So I enter these 3 pieces of information, and I hit enter, and then I have my z statistic. Okay, my z statistic again compare how far this sample mean is from the population mean divided by the standard error of the mean. Now that I have this piece of information, I can go ahead and work on the confidence level. Okay, so let's work on the confidence level, and the confidence level comes from the problem. Let's take a look at the problem. The problem doesn't say anything about confidence level or alpha level. Oh, there you go. Here we have the FTC director wants to perform a hypothesis test with a 0.01 level of significance. This is alpha. 0.01 level of significance here is the alpha. Okay, so I don't have to type confidence level, I don't have to type confidence coefficient. The level of significance or significance level or alpha is 0.01 is given in the problem. So I don't have to use this piece of information to compute the alpha. Remember, I told you sometimes the alpha is given to you in the problem. Sometimes you have to compute if you only have the confidence level. Okay? In this case, it's given in the problem, so we don't have to compute. Because this is a lower tail test, we don't have to divide by 2. We don't divide by 2. Okay? And then we can go ahead and use the approach to solve it. I know that is a lower tail test because of the hypothesis, so I'm going to compute the probability in the lower tail. The probability in the lower tail, according to our slides and what I've been working on, is equal to norm.s.dist, open parentheses, and then you select the z that we want. This is the z we found, and then type comma, and then type 1 to say that it's cumulative. Okay, and then close parentheses. So this is the probability that we have to find this z statistic in the distribution of z. Okay, now I can compare the probability, the p, with the significance level. If this p is smaller than the significance level, I reject the null hypothesis. We see that we have too many decimal points, and here only 2 decimal points. So if you want to reduce the number of decimal points, you can go up here on this, like in this section, and here there are zeros going to the right and to the left. You can select this one, decrease decimal points. So if you decrease the decimal points, the same number of decimal points that we have in the significance level, it is easier to see that this p-value is smaller than the alpha level. Okay, because it's smaller, then I reject the null hypothesis. Reject null, and conclude that the cans of coffee has less than 3 pounds. Okay, you see that this cell is messy. Okay, I can format that. This is what I'm gonna do. I want to make this within this blue box that I colored here. So I'm gonna select that holding the mouse, and then I go up to this alignment section, and I go to margin center and go to wrap text. Okay, so we are done with the p-value approach. Now we can go to the critical value approach. The critical value approach, what we have is we have to find a z critical for this alpha level. So what is the z critical associated with this alpha? Because it's a lower tail, I only do for the lower tail, I don't have to do for the upper tail. So for the lower tail, what I have to type is equal norm.s.inv, because this is the inverse. I have the area and I want to find the z. And then open parentheses, and then I select the probability or the area, which is 0.01. A lower tail, I don't have to divide by 2 because it's only one side, only one tail. Okay, then I close parentheses, and then I get that. So I have my z critical as minus 2.33, and my z statistic is minus 2.67. So I have to compare my z statistic with my z critical. If this z statistic is smaller than the z critical, I reject the null hypothesis. And minus 2.67, and if is even smaller than minus 2.33. So in this case, I reject the null hypothesis and conclude that the cans of coffee has less than 3 pounds. Okay, again, this formatting is messy. I'm gonna select everything, come here, merge and center and wrap text, and is now centered. Okay, so this is how you solve a lower tail test, lower tail hypothesis test when I know the population standard deviation.